Welcome to Learning Through Math, the podcast. I'm Laura at I Teach the Why.
I'm Karina at Mrs. Cousins 5. Our mission is to inspire ourselves and others to keep learning and improving with passion.
And hugs! You can find us at learningthroughmath.com and on Twitter at Laura and Karina.
Come and join us on this journey of learning.
Thanks for joining us. We are recording this in July of 2020.
And welcome to episode 4, 13 Rules That Expire. This episode is based on an article written by Karp, Bush, and Dougherty, and we will include the article in the show notes.
This is one of my favorite articles to use with teachers.
I agree. It's chock full of great information and
ways for us to change our mathematical language and practices with our own students. So before we get into this episode, let's reflect a little bit about the last episode with CRA, Concrete, Representational, and Abstract, something that happened that we actually just did.
Yeah. When we reread this article, there was an example given about subtracting two negative numbers. And I looked at Laura and I said, well, I know how to do this abstractly because that's how I was taught. I know that when you subtract a negative number, it's just a positive. So you change the sign, but I have no idea what that looks like. So I asked Laura, I'm like, what let's think of this concretely. What would we use to represent this?
And I remember being in a training a few years ago, and I remember that the person used two colored counters. Since I have my whole classroom here at home with me over the summer because I'm changing schools, I grabbed the two color counters and I said, I know it has something to do with this. So we started to play around with it, and then
we still couldn't figure it out.
Then we went on
YouTube.
Yep.
Searched for a video, found one, and then just had an aha moment.
That light bulb turned on.
Yep.
Even for us, since we don't live in that integer world.
Right.
In elementary school.
If you're a middle school teacher, please take out those manipulatives and teach with those red and yellow counters.
If you don't have any, just find your friend at the local elementary school because I'm sure everyone's got them in their closets.
Yes. Now it makes a lot more sense.
Yes.
And now I understand.
Our aha. Let's dive into the 13 rules that expire.
So rule number 1. When you multiply a number by 10, just add a 0 to the end of the number.
Oh, gosh. And I can hear 3rd and 4th and even 5th grade teachers saying this because when you multiply by a power of 10 with a whole number, it's so natural just to say add a 0 at the end.
It's hard to get out of that language. So being a 5th grade teacher, what I do is we're just always going back to looking at the patterns of the numbers as opposed to talking about just adding a 0 to the end. And the reason why this is a dangerous rule to teach is that when we're multiplying by decimals, when you multiply by a decimal, you don't just add a 0 to the end.
Right, because some of my students would literally put, 0.25 and then just stick a 0 on the end.
Yes.
When it was 25 hundredths times 10. No.
Right. We talk about shifting the digits and shifting the decimal, but doing both of them is really important.
You and I talk a lot about shifting digits versus shifting the decimal because in our place value system, the places don't change, the decimal point never moves.
Yes.
We tend to talk about shifting the digits because that's what's happening.
Yes.
Since this expires in grade 5, we really want, especially the 3rd and 4th grade teachers, because they're the ones, 3rd especially, they're the ones introducing multiplication, not to fall into that trap of saying add a 0. And I don't know about you, but I know that when I do a number talk and a student literally says add a 0, I put plus 0 when I'm facilitating a number talk because I want them to be mathematically precise, which is one of the mathematical practices that we want our kids to be able to do.
And I just want to point out that this rule expires in grade 5. If you look at the articles and you just pay attention to the expiration date to all of these rules, there are 5 of them that expire in 5th grade and 8 of them that expire in elementary. So it's really important that as teachers,
mathematically precise with our language.
Yeah. Let's move on to rule number 2. Use keywords to solve problems.
This is one of my babies.
Yes. There's one thing that I just want to quote from the article. It says, using keywords often encourages students to strip numbers from the problem and use them to perform a computation outside of the problem context. And I think that there's a word that you've kind of used a lot, or a phrase.
You mean number pluckers?
Number pluckers. They're number pluckers. They just grab the numbers and they just do.
Actually, usually kids just add the numbers.
Yes.
Even if the story problem has nothing to do with addition, that's all they do. They pluck out numbers.
And if they know we're multiplying or dividing, they'll just multiply.
All of them.
Yeah.
Right.
Doesn't matter.
It doesn't matter.
I also want to quote Julie Dixon on this. She says the keywords are evil.
Evil.
And we'll post, there's a blog post that she has written about how keywords are evil. So we'll include those in the show notes.
That reminded me, there's another book that I came across a few years ago that's called Nix the Tricks.
Yes.
By Tina Cardone. We'll link that in the show notes as well.
Yeah.
Yeah. Which has to do with all these kinds of tricks and rules that expire. So
that's a great one. And I think the whole book is available online.
It is. So we can link that on the show notes too. I'm just going to take the example that's in the article. Says John had 14 marbles in his left pocket. He had 37 marbles in his right pocket. How many marbles did John have? You know, if people are saying keywords, you see the word left. Doesn't that mean to subtract?
It does.
It does. Not in this case.
No.
And keywords become a very huge problem, honestly, when it becomes a multi-step word problem.
Yes.
And I like to call them story problems because they do have a beginning, a middle, and the answer is usually the end. This rule expires in grade 3.
Yeah.
Grade 3.
It's an early one.
It is. So we've got to take down cubes, and we have to take down our keyword posters. Just, you have our permission to burn them.
Yeah.
Well, okay, maybe if they're laminated, don't burn them. Maybe just throw them in the garbage.
Yeah, it's at the end of the day, it's just not helpful for kids.
It's not. They have to make sense of what's happening in the story for the context. Another site that I just thought of was Numberless Word Problems.
Yes.
That's another one of my favorites, where you actually just take the numbers out of the story and have the kids read line by line and say what's happening, restate what's happening in that story. Don't even put the question at the end.
You know, I think of too the video, and I forget you're going to tell me where it came from.
Okay.
The video with the problem, they had I want to say teenagers or adults trying to solve this with the shepherd, and how old is the shepherd?
That was Robert Kaplinski. Yes.
So I always think about that when I think about trying to teach keywords or the dangers of teaching keywords, is that they don't make sense.
It was a complete nonsensical word problem. We'll link that to the show notes so everybody can look at that video.
That's a great video. Moving on to rule 3. You cannot take a bigger number from a smaller number.
This rule expires in grade 7 because we're talking about integers. You can take a bigger number from a smaller number. You just get into the negative space, into the negative world.
What I always use as my example in my classroom when we talk about this is that if I have $5 in my bank account and I owe you 10, I can take out $10 and give it to you, but my bank account now is...
you owe the bank.
Right. When I address this in my classroom, I always use money.
And when I address this in my classroom, I talk about two things, either above and below sea level, and then I can kind of also tie it into science.
Yes, that's a good one.
And I also talk about elevators. So we live in Florida. We don't have basements or anything like that, but sometimes we have parking garages that go below ground, and I bring that into my classroom.
And of course, temperature, right? We can talk about that too.
And of course, that's hard for our kids to visualize because we don't have snow days or anything.
It's always hot down here.
I had a kindergarten teacher this year tell me that one of her kindergartners was talking about negative numbers. She was able to tell me that story about that 5-6-year-old using negative numbers. So even though it says it expires in grade 7, we want that not to be taught throughout the elementary school years.
Right. Rule number 4, addition and multiplication make numbers bigger.
Ooh, we definitely know that expires when it comes to multiplying decimals and fractions.
Yes. In episode 3, we had talked about, one of my examples was using the tiles as a new area, using the new model. So 1/3 times 1/3 is now 1/9. And that is such a difficult concept for kids. And even me as an adult to go back and to really rethink that.
Well, and we live in the whole number world most of the time. So since that's what most students have been exposed to, even, I mean, they start fractions in 3rd grade and 2nd grade, but really they don't get into it until 4th grade. So if they've had 6, 7, 8, 9 years of living in the whole number world, it's very hard for them. Kind of the same thing when we talked about using manipulatives and having that small cube represent 1. Well, guess what? In 5th grade, I'm going to make that represent 1/100th or something.
Yeah, right. And because every time they've seen multiplication up to this point, it has created a product that's larger, greater, right, than its factors. I totally get where it comes from, but it's so important that as teachers, we make the students aware that it's not always the case. That yes, right now these numbers are getting bigger, but they won't always necessarily mean that the product is larger than the factors.
Which ties right into rule number 5 that expires: subtraction and division make numbers smaller.
Yes. Again, same thing.
So this expires in grade 6 and again at grade 7. But think about when we're dividing fractions. When you divide a fraction by a fraction, your result is greater than what you started with.
Yeah. And I referenced explosions in my classroom. Yeah. This is again like, oh, multiplication, you're getting a smaller product. Explosion. Division, you're getting a larger quotient. Explosion. It's all these moments in 5th grade that change their understanding.
Because they've been taught these rules throughout. So we as teachers have to be very explicit with our language when we're teaching. If we look at rule number 6, you always divide the larger number by the smaller number.
Oh, here we go again. Another 5th grade one. We will have examples of 2 cookies. I am going to share them equally with 4 people, and every time we get the division sentence 4 divided by 2.
Always.
And I ask them, well, wait, what does that 4 represent in the problem? And the kids are like, well, those are the people.
4 people.
And I'm like, so are you breaking apart these people into 2s? And then, of course, they're like, no, we can't break apart people. So I'm like, okay, so we need to rewrite this sentence to make sense with the problem.
Exactly. Now let's look at rule number 7 that expires. 2 negatives make a positive. This expires in grade 7, which references back to rule number 5, subtraction and division make numbers smaller. It's just another one of those things where it's not always true.
Right.
So we can't say this always happens. In this case, here's what happens. In this case, and maybe that's the kind of language that teachers need to be using, as well as ourselves.
Right. I often say in 5th grade, and then I'll continue with what we will see and what they'll be exposed to, and then I'll say, but in 6th grade, that's going to be different.
Yes.
So I think that that's helpful for students just to know and kind of put an asterisk next to their learning that, okay, this will work for me this year, but next year I'll understand it in a different way.
Right. Rule number 8 says multiply everything inside the parentheses by the number outside the parentheses. This goes back to distributive property right here.
Yes. And how important distributive property is.
And using those area models and the concrete representations to show that if you have, let's say, 3 times open parentheses, 5 plus 4, close parentheses, that it's 3 groups of 5 plus 3 groups of 4.
Right. And that's not the same as 3 open parentheses, 5 times 4, close parentheses.
And we're going to talk a little bit later about order of operations, because that's another rule that they bring up.
Yeah, so we'll pause this conversation as we move on to rule number 9. Improper fractions should always be written as a mixed number. Now, I do wonder why they wrote improper fractions and not fractions greater than 1.
I'm looking at the date, the publishing date, and it was 2014 of this article. However, in the middle school world, I think they do still commonly say improper fractions. And I know I do, I'm sure you do. We say it both ways in 5th fifth grade that it's improper fraction, but it means a fraction greater than 1 because we need them to understand the foundation of where improper came from. It's not just that the numerator is greater than the denominator. We need them to understand what it looks like and what it actually means.
Yeah, that's so important. So we don't always want them to change the improper fraction or the fraction greater than 1 to a mixed number, especially as the article says, when you're learning about the slope of a line. So that comes in a little bit later in 7th grade. I think the most important thing too is for them to just be flexible with their numbers.
Absolutely.
It goes back to that. It goes back to...
I mean, sometimes there's a purpose to write it as a mixed number.
Yes.
Before you compute with it.
Right. I know that to understand, if I'm talking about a measurement, if you're going to say that it's
1 3/8, I'm really not going to say 11/8. I'm not.
Right.
Because what's the unit? Is it 1 3/8 feet? 1 3/8 inches? I'm not going to say 11/8 inches.
No, that doesn't make sense. You can't visualize that.
Exactly.
You can't.
Rule number 10 says the number you say first in counting is always less than the number that comes next.
Oh, yes. Their example here is if you have 3 dozen eggs, that's more than 8 eggs.
Because it goes back to the size of the unit.
Right.
Which is why I'm always saying you can't just say the numerical answer. You have to tell us what you're measuring, what you're counting. What are you talking about?
I do too. When they say, oh, the answer is 3. 3 what? 3
bananas?
I
I say 3 cupcakes. Cupcakes is my go-to.
Bananas are mine.
No, sometimes I do say donuts. Oh. Food. Yay.
Right? We always go back to food.
Rule number 11 says the longer the number, the larger the number.
And again, back to decimals.
And look, this expires in grade 4.
In 4th grade. This is a big one, especially when they have to compare decimals. So for this one, I don't think that it's explicitly taught as if you have a longer number. I don't think teachers are saying that. If you have a longer number, then that number is greater than the shorter numbers.
Going back into the whole number world.
Right.
So when we go into the decimal world, it all comes back to place value, the value of each place. Yes. And I love the example that they put in here that kids think that 273 thousandths is greater than 6/10 because there's only one digit behind that decimal point in 6/10.
Number 12. Oh, I'm already smiling at this one. Please excuse my dear Aunt Sally. Or PEMDAS, or BEDMAS,
or GEMS, or I don't know.
There's so many out there.
So many. We need to teach it as order of operations. Yep. Triple O.
And here's the danger. Here's the big issue with this is that, because I know teachers will say, but that's how I've always taught it, and then they remember it. The problem with it is that students, when they see multiplication and division, they immediately think that multiplication is first.
Yep.
No matter where it is in the expression.
Same with addition and subtraction.
Right. Because of that order.
Yep.
The way that I've done it in my classroom, I've taught this, is to use it almost like a pyramid, like boxes. And I write the P on the top, and then multiplication and division on stickies, and then subtraction and addition on stickies, so that I can move them around. And one day it'll look like this with the D and M, and one day it'll look like, I'll flip it, so that they understand that those two are equal.
They have the same priority level. That's what I tell them.
Like a hierarchy, right? Like they're on the same level. I kind of talk about a building too, and we want to go from the top floor to the bottom floor, and division and multiplication are on the same floor.
Okay, that makes sense. I think it's fine to use a mnemonic device, but you have to have disclaimers in them. 3 years ago, I was working with a 5th grade teacher, and I pulled out Danica McKellar's book, Math Doesn't Suck, and Kiss My Math. And she, which I'll link in the show notes, she explained it using a dinner and dessert kind of thing, where it was something like pandas eat mustard on dumplings and apples with spice. Or it could be pandas eat dumplings with mustard and spice on apples. And her whole thing was to say that you can't just say PEMDAS, because that's not what it is. She went through this. So whatever I ended up teaching the kids, one of the kids after our state test, because we had done order of operations preparations at the beginning of the school year that year, he came up to me and said, Miss, I remembered what you had taught us about the pandas eating everything. And he said he got the question right because of this is the appetizer, this is the entree, this is the dessert. However I explained it to him, he remembered, and he went from left to right on that multiplication division and left to right on the addition and subtraction. I was so proud of him. Yeah. Honestly, I don't know if he got it right because I didn't get to see his test, but I was excited.
He was confident. He was confident.
Number 13 is probably one of my absolute favorites, and this rule expires in grade 1. It is, the equal sign means find the answer or write the answer. We have to be teaching, even in kindergarten, that the equal sign means the same as, or that symbol is a relational symbol. Whatever's on this side of the equal sign is the same value as that side of the equal sign. But it doesn't mean, dun, 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 we have to do something.
Right. Yeah, I totally agree with everything you just said.
Did you like my dun, 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 dun?
I did.
So let's talk about that expired language.
This is in the table of the article. I mean, the first one that I want to I want to go right to it. It's using the words borrowing or carrying when subtracting or adding.
And that's how we were taught. So we have to not fault teachers that are still using those words, because if that's all that they knew, and once we know better, we do better.
That's right.
We just have to be explicit with our language and change it to trading or regrouping, because you should have those concrete manipulatives out.
Right.
Those base 10 blocks or the counting cubes or something where they have to trade up or trade down or exchange amounts of things.
Yeah. I think the danger here too is that when you're using the language of borrowing, it kind of implies that you're going to
give it back.
So that's where we want to be more precise with our mathematical vocabulary.
Because we've all heard, really, go borrow a cup of sugar from the neighbor. What? There's no sugar involved. I don't know where.
Go knock next door.
Knock next door. And I'm like, we're not borrowing because we're not giving it back.
Because it's actually the same number. See, that's the thing too, right? If we have 34, 3 10s and 4 1s, that's the same as 2 10s and 14 1s. So it's just renaming the number in a different way.
And that goes back to first and second grade teachers. Technically, the kids shouldn't even be exposed to the standard algorithm until they have a firm understanding of addition and subtraction. Same with multiplication and division, but we're talking about grade 1 right now, borrowing and carrying.
But in 5th grade, this is so big when we are renaming decimals.
Yes.
And it's so important for them to understand that 60 hundredths is the same as 6 tenths.
Yep.
And they don't see that right away.
There are 8 stated phrases that we commonly use, and then they give alternatives of what should be stated. I just think the other one that's super important is reading the equal sign as makes. For example, saying 2 and 2 makes 4, 2 plus 2 equals 4, to not state that, and instead to read the equation 2 plus 2 equals 4 as 2 plus 2 equals, or 2 plus 2 is the same as 4, because that's showing that it's a relational relationship and not just I have to do it.
And it goes back to Rule 13.
Yes.
So it really, those ones really come together nicely. And I'll just plug the last one. I know we don't want to go through all of them for the fraction. Yeah, the top number and the bottom, please just name them, just numerator and denominator. I mean, I think it's really important for students to know the proper language.
Not just that, but that students should see fractions as one number, not 2 separate numbers. There was one more thing I wanted to say about that equal sign. I know it's not in this article, but please, teachers, don't always make the sum or the difference or the product or the quotient always on the right side of the equal sign. Please flip the expression or the equation so that it looks differently. And for that, you can go to the appendix in the Common Core State Standards. I'll link that. We'll link that as well. That was a lot. Sorry if that went a little longer than what we had hoped for, but all of it is super important.
It is. And it's such a good article. I read it years ago, and and I'm glad that we revisited it. I think it's an important one. It's important to have those conversations with your teams. It's important to have the conversations with your students.
Yes.
It's important to self-reflect as a teacher and say, where have I, when I look at myself in my own teaching, I definitely have said out of.
Oh, absolutely.
With fractions, for sure. So I need to be more...
And don't beat yourself up if you've been doing this.
Right.
Because now that you know better, you do better.
Right. But it's a good article to, I feel like you always, when you read it, you always get something else out of it.
Something else. And I've read this article many, many times, and it always brings back things to my mind.
Yeah.
Now we're going to go into the challenge.
Our challenge for today is, of course, to read the article. We will link it in our show notes. The question that we have for you to reflect and think about, what is one of these rules, or maybe the language in the chart, what is one thing that you'll teach differently, that you'll
Talk
rethink
about differently
now in your classroom. Thank you so much for being here today and listening to us.
We'd love for you to subscribe to our podcast and give us a 5-star review on your favorite podcasting platform. We invite you to join the conversation on Twitter by using the hashtag #LearningThroughMath.
We'd love to hear your feedback. Make sure to tag us at Laura and Karina. It's always a pleasure to talk to you.
To you too.